Okay, this is a little tutorial about the graphs. So these are conservation momentum graphs, and the law of conservation momentum says that the momentum before the momentum interesting the momentum before would be conserved, which would mean that it would be the same as the momentum after. So another way to say that is the MV net, or the total MV before, would be the same as the MV net after, where of course this is before and this is after. Well, before or after what? In this case we'll give some examples. So in all these cases we have the before and after the event being a collision of some sort. So right down that line is the before/after line. So there's before and there's after, right down that line right there. And same thing here, we have the before and after, and the same goes for this one, where that's the line right there for before and after. Excuse me. So in all cases we have this idea about the momentum on this side is going to be equal to the momentum on this side. The momentum on this side is going to be equal to the momentum on that side, etc. and so forth. So how we can look at this is that this right here is a mass times a velocity, and below it you have a mass times a velocity, and you add those two things together and you get the before, which is mv plus mv, and that will be equal to what is after. And so maybe I will carry on the same color here. This is the same car, mv plus mv, which means that they are still separate. They are not connected. So this is what we call an elastic collision, because it is bouncing off of each other, and where this is the before and after. You fill those numbers in, and these two numbers should match these two numbers, and that's our equation. In the next one, same thing is true. We have mv and plus mv. So in the beginning they are separate, mv plus mv. However, after the collision, so here's our line right here, dividing line, and after the collision now you have m and v together. So this is m plus m times v. So in this case we're going to group them together at the end, and you have m plus m. And in the last case scenario is like the scenario of the cannon, where the cannon is together with the cannonball. So before we have m plus a little m for the cannonball, and they are together, and then afterward they are now separate. So you have the cannonball and you have the cannon separated, the larger one in this case being the cannon, and the smaller one being the cannonball. And all those three examples are examples of how these graphs fit directly with the equations that we have.